Hi, this is Victor and welcome back to my math tutoring channel. I ended up my previous video by an example of how to change variable in an integral. We use that when we have an integral that seems to be difficult, but it will be way easier if we change the variable inside. I'll give you an example. If I have an integral of 2x plus 3 squared dx. This is easy. I don't have to change variable inside this because this is like a plus b squared, which is equal to a squared plus 2ab plus b squared. So if I apply that formula, that is my a and that's my b. So a squared become 4x squared plus 2 times 2x times 3 plus 3 squared is 9 dx. So it become integral of, I'll write it here, 4x squared plus 12x plus 9 dx. And this, because there is a plus, I can write it into many integral. It become 4x squared dx plus 12x dx plus 9 dx. So this is 4x3 divided by 3, and this become 12x squared divided by 2 plus 9x plus c. And that's it. That's an easy. We don't need to change the variable inside. But imagine I have an integral like this now. The integral of 2x plus 3 to the power of 40 dx. Trying to solve this in the method that we saw here will be very, very difficult. But if I say let u equal 2x plus 3. Then I have my du, the derivative of u is equal to dx. Yeah. So I have dx here and I have dx. There is a 2 that's bothering me. I want to get rid of it. So I will put dx is equal 1/2 or du divided by 2 or 1/2 du. So my integral will become 2x plus 3, I will replace it by u to the power of 40, and my dx will be times 1/2 du. So the 1/2 go outside the integral, it become 1/2 u40 du, and that's very easy. It become 1/2 u41, 40 plus 1 is 41. Let's write it right away. I think you're used to it now. I don't have to explain it to you all the time. Divided by 41, it is equal u41 divided by 81, because 2 times 41 is 82. And now I have to put back u to its value. So instead of u, I will write 2x plus 3 to the power of 41 divided by 82 plus c. So in such cases, it's easier to change values. I'll give you another example, and you will see how by changing the variable will be much easier. Let's do integral between 2 and 3 of x squared 2x to the power of 3 plus 4 to the power of 3 dx. Now I look here, if I take this as u, my du will become 6x squared divided by 6x4 divided by 4. Yeah? So, no, it become, let's do it. Let u equal 2x to the power of 3 plus 4. So my du, it becomes 6x2 actually, dx. I see here there is x2 dx, and here I have x2 dx. There is the 6 that's bothering me. So what I do is I divide here by 6 and I divide here by 6. So become du over 6, or 1/6 of du, equal x squared dx. So my x squared here dx, I can replace it by 1/6 of du, and this I will replace it by u to the power of 3. But now that I cannot, if I want to replace by u, I cannot put between 2 and 3 because x is between 2 and 3. So if I want, let's write it and then we change those variable, those numbers after. So it become of u to the power of 3, and this is 1/6 outside, du. Because x2 dx, it's 1/6 du, and this is u to the power of 3. But now, if I want to see the boundary, I put u equal to x3 plus 4. So if I take, let's say, the two boundaries here, u equal 2 times 2 to the power of 3, because I replaced x by 2, plus 4. So u equal 2 times 8. 2 to the power of 3 is 8, plus 4, 2 times 8 is 16, plus 4 is 20, so I put here 20. And then I take the upper value, the upper boundaries, it become u equal to 3 to the power of 3, plus 4, and 3 to the power of 3 is 27, and let's do the calculation, take the calculator, 27 times 2, equal to 54 plus 4, which is equal to 58. So my boundary become between 20 and 58 now. And then that's easy to solve. It's 1/6 u4 over 4 between 20 and 58. And so the first time I replace u by 58, and the second time I minus it, replacing u by 20. So it's 1/6 times 58 to the power of 4 divided by 4 minus 20 to the power of 4 divided by 4. And the answer, I multiply it by 1/6, and that would be my answer. Let's do another example. If I have the integral of e to the power of x sine of e to the power of x dx. By looking here, if I take my u e to the power of x, my du will become e to the power of x dx, because the derivative of e to the power of x is e to the power of x. So let u equal e to the power of x, my du equal e to the power of x dx, which it's e to the power of x multiplied by dx become my du, and sine u. So it become sine u du. And we know the derivative of cosine is minus sine, so the integral of sine is minus cosine. So this will become minus cosine u plus c, and here I replace u back to its value. It become minus cosine e to the power of x plus c. And that would be my answer. Let's continue with another example. If I have integral of e to the power of sine x cosine x dx, and I want to have boundary between pi over 6 and pi over 2. If I look at it, it looks complicated, but in reality it's not. The thing that's bothering me the most is e to the power of sine x, but if I have e to the power of u, it will become easy. So what I take, I will say let u equal sine x. So my du equal cosine x dx. You see this here? That become my du, and then it become e to the power of u. So by changing the variable, you see that my integral become very easy. And then we will do the boundaries of my integral later on. So this will become e to the power of u du. And now I want to see what should I put here instead of pi over 6. I replace my x by pi over 6 in my u. So u equals sine of pi over 6, and sine of pi over 6 is equal 1/2. So I will put here 1/2, and if I put u sine of pi over 2, sine of pi over 2, which is equal to 1, so between 1/2 and 1. So the derivative of e to the power of u is e to the power of u, so the integral of e to the power of u, it's e to the power of u. So my answer here is e to the power of u between 1/2 and 1. So this is equal e to the power of 1 minus e to the power of 1/2. So, or it become e to the power of 1 minus square root of e. And we know e is 2.7 on 7.2, I guess, on your calculator, but e to the power of 1 minus square root of e is the final answer. I want to do short videos. I will stop here this video, and then I will see if I need to do more video on that. Actually, at the end of that chapter, I will do way more videos. So if you like my video, again, I insist, please subscribe to my channel. That will help me do more video for you, and it will help you pass your course. Thank you.